Way back in chapter 2, we learned what would happen to a distribution if we added or subtracted, or we multiplied or divide. We learned what would happen to the measures of center and the measures of spread. For example, we have this distribution. 1, 2, 3, 4, 5. That's our distribution. What is the mean of that distribution?
3.
What is the median of that distribution?
3.
What is the standard deviation of that distribution?
1.
Exactly. Hence why you need your calculator. Please go to your L1 list and type in the numbers 1, 2, 3, 4, 5. And then find the standard deviation using your one variable stats. So,
I'm not gonna lie, I don't remember how to tell.
stat edit. And then you put in 1, 2, 3, 4, 5. Now guys, listen very carefully. Remember, last week we were doing probabilities and therefore you had to put in an L2 under the frequencies. You are probably getting an error if you left the L2 there. You need to take out the L2 because this is just a list of data that is all equally likely to happen. So you just need to take the L2 out of your frequency. So if you go to StatCalc 1, leave the frequency out. So delete the L2. And what is your standard deviation?
1.581.
All right. Now, does anybody remember IQR?
Quartile 3 minus quartile 1.
Quartile 3 minus quartile 1. Now, if you guys do a little scrolling down on your calculator screen right now, you'll see what quartile 3 is and what quartile 1 is. And what is quartile 3? 4.5. And what is quartile 1? And so what is the IQR? 3. All right. So ladies and gentlemen, here's what we know. We know all this information about this little bitty data set, right? Here's what we're going to do. We're going to add 10 to every single number. So what is our new distribution?
110.
11, 12.
Now, let's think. What is the new mean of this distribution?
13.
What is the new median of this distribution?
13.
What is the new standard deviation of this distribution?
You have to recalculate.
Go ahead and recalculate it.
Are you kidding me right now?
No, I am not kidding you right now. Go ahead to list 1. Go back to your list. Change your numbers. And recalculate.
I have a feeling, a sneaking suspicion it's going to be the same number.
All right. What do you guys see? How is it the same?
Because you're changing the ratio. There's a ratio of how distant they are.
Very good. Standard deviation is this average distance from the mean. The mean here did move up, but the distance from the mean didn't change for either of these distributions. They are both equally spread out. Okay? So the standard deviation is exactly the same. What about the IQR?
Same.
It's exactly the same as well. Now, very important question here. Is Q3 and Q1 the same?
No.
No, but the distance between Q3 and Q1 is the same in both distributions. All right, so what did we just notice here? What did we just experience?
The adding does not change the thing.
Adding does not change what things?
The IQR or the standard deviation.
These are called measures of spread.
Measures of spread.
Spread is not affected by addition or subtraction. Now, what happened to the mean and the median?
Oh, they got moved.
Them things are different.
We added 10 to, we added 10, not 2, added 10 to
Put the deer in it.
each. Just like we added 10 to every number in the distribution, we added 10 to the mean and the median. But the standard deviation and the IQR is not affected. Guess what else is not affected? The range would also not be affected. Now, the max and the minimum did change, but the difference between them did not change. All right, you guys, back to the original. Back to the original distribution. Whoops, so sorry, my bad. Wrong one, there we go. Back to the original distribution. 1, 2, 3, 4, 5. Here's what we're going to do now. We're going to multiply each number by 10. What is the new distribution? 10, 20, 30, 40, 50. What is the new mean? 30. What's the new median? 30. What about the standard deviation? Did my data have a different spread now?
Yeah.
It does. So what is it? Danny thinks it's 15.8. Where did you pull that number out of, Danny? Because I see your calculator still has its little cover on. There you go.
Wise guy.
So guys, here's the cool thing. That just got multiplied by 10, just like we thought it might have. What about the IQR? You think it's 30? You would be absolutely correct, sir. The IQR is 30. How did we get to 30? We multiplied the original IQR by by 10, sorry. The original IQR was 3, so we multiplied by 10. So what do you guys see about this?
You want to put the bay on.
Just let the deal.
All values were multiplied by 10.
Why?
Cool, huh?
Very cool.
Because the range change.
I like that.
Spread change.
All right, so let's summarize what just happened. You guys ready to summarize what just happened?
Okay, I understand.
Let's summarize.
Okay, fresh new paper.
What is the effect of adding or subtracting a constant?
Mean and median, increase or decrease.
Okay, so center, we're talking about mean and median, is changed by same value. If I add 10 to every number in the distribution, I'm going to add 10 to the mean, add 10 to the median. If I subtract 15 from every number in the distribution, I'm going to subtract 15 from the mean and the median. Okay? Guys, you do not have to constantly be talking. All right. Spread. I'm talking here about standard deviation. I'm talking about IQR. I'm also talking about range. Is not affected. Range is, or standard deviation, IQR, and range is not affected. All of the spread is not affected. This is all for addition and subtraction. Multiplying or dividing. All values of center and spread are changed by the same factor. If I multiply by 20. I'm going to multiply every measure of center and spread by 20. If I divide by 4, I'm going to divide every measure of center and spread by 4. So whatever I do to the distribution, I'm going to do that to the center and spread if it's multiplying and dividing. So guys, really the only funky one is the standard deviation and the IQR and the range, the spread, for addition and subtraction. Everything else just kind of gets the same transformation as the distribution gets. All right, let's look at an example. El Dorado Community College. El Dorado Community College. A student is considered to be full-time if they are taking between 12 and 18 units or hours at this El Dorado Community College. We're going to let X be the randomly selected El Dorado Community College full-time student and the number of hours that they're taking. Here's their distribution. Hey, what's the probability that I select a student from this college and they're taking 15 hours? 15 hours. Okay? What percent of the students are taking 17 hours?
5%.
5%. Okay, do you guys understand this?
Absolutely.
Perfect. Please calculate the mean and the standard deviation of X. How are you going to do it?
I'm a little whippy little chopping in.
L1,
We'll go get the stop and let everyone know.
L2. Ready, go. Calculate the mean and standard deviation of this chart. We're about to do it, right? Yep, it's coming.
Because you've been like leading us up to this point.
Get ready.
And like,
I'll tell you what, now, the whole
L1
time
and L4.
All right, did we get a mean?
yes,
I told you.
Now, careful. How do you write the notation for what you just found for the mean?
X bar.
Nope.
What?
Mu sub X.
Okay, well, what if I kill you?
What is the mean? And the standard deviation of X? It does. Look down there. 2.06.
5.6.
All right. Now we get to interpret. If we select many students, they will take 14.65 units on average. This typically varies by 2.06 units. You call up your bestie who's taking classes at El Dorado Community College. And you say, hey, how many classes are you signed up for? How many units are you signed up for? And they say, oh, I'm signed up for 18. Are you a little surprised?
They are an outlier.
Yeah, you should be a little surprised. What if they say that they're signed up for 13?
You
Probably not that surprised.
You're kind
Okay.
of below average.
Cool. Do you guys have any questions about that? Now, here's what we're gonna do. We're gonna take this and put it together with what we just talked about. So here we go.
Bring the heart of tongue.
At El Dorado Community College, the tuition for full-time students is $50 per unit. If T is the tuition charge for a randomly full-time student, T equals 50 times X. What do you guys notice about the probabilities of this chart and the one right before?
Hold on a
It's
second.
the same?
Hold on.
Why?
All right.
Yeah, so you guys, if a student is taking 12 units and it's $50 per unit, 12 times 50 is 600. And 25% of students are taking 12 units, so 25% of students are paying $600. So, we need to get the mean and standard deviation of T. What is the mean of T? Well, all I have to do is multiply 50 times the mean of X. 50 times 14.65. $732.50.
I was $20.
Oh, it's been
That is how much money a student will pay on average for tuition. What is the typical deviation of money paid for tuition? How am I going to get from the original
2.05.
multiplication does affect standard deviation, so I'm going to do 50 times standard deviation of x. So 50 times 2.06, which is $103. So if I select many students, they will pay on average $732.50, and that typically varies by $103. Cool? That's, if you're writing money and there's no cents, you can do a little line. All right, guess what, you guys?
Stop now.
That's not all we pay for. In addition to tuition, each full-time student at El Dorado Community College is assessed student fees of $100 per semester. If C is the overall cost, then C equals 100 plus T. Hey, you guys, what do you notice about the probabilities of this chart? What happened to the first line? By how much? $100 per number. So I added 100. The mean of C can be found by taking 100 and add that to the mean of the tuition distribution that we just used. So I'm going to do 100 plus $732.50. And now I have $832.50 for tuition and fees on average. How about the standard deviation? What? So watch this. 100 plus the standard deviation of t. And I am going to cross out that 100. Why? Addition does not affect spread. And now I'm just going to simply write 103 because that's what it was. Does that make sense? Do you have any questions? Could you have just retyped in the chart every time to your calculator? Yes, but why?
Waste time.
To waste time, yeah, sure, because we all have time to spare, right? We're all just sitting around looking for something to do.
Yep.
Might as well, right? You could. That would work. You'd get the same answers. But sometimes you're not always given the chart. For example, this problem. Dun, da, da, da. In a large introductory statistics class, the distribution X of raw scores on a test was approximately normally distributed with a mean of 17.2 and a standard deviation of 3.8. If the professor decides to scale the score, he's going to do so by multiplying the raw score by 4 and adding 10. Here's what we would do. We would take the raw score of X, we would multiply by 4, and we would add 10. That's how we would scale this. That is the transformation equation.
Bro, this is
Yeah, this is like algebra.
Is it?
Come on.
We're going to define variable y to be the scaled score. Oops. Y is the scaled score of a randomly selected student in the class. Find the mean and the standard deviation. What is the mean of y going to equal?
It seems that we've caused another explosion.
4 times the mean of x plus 10. 4 times 17.2 plus 10. This will be the mean of the scaled score.
it's just gonna be hard to remove all.
That's what we got most.
And what do you get? All right, how about the standard deviation?
Wait, do we not do the plus 10 because it doesn't?
For standard deviation, we won't do the plus 10. I'm going to write it and then I'm going to cross it out immediately because addition does not affect standard deviation.
Is that 4
Is it always
and then
gonna
standard
be like,
deviation?
Yeah, 4 times the standard deviation of x.
No, not C.
like mu y equals 4 times mu of x? But is it always gonna be mu of x is the second number?
It depends on what distribution you're transforming.
No, that's
That's the reason that the x is there is because that's what they define that distribution was for x. All right, so 4 times 3.8 is what?
15.2.
This is rather unsavory.
Well, ladies and gentlemen, we now have the mean and the standard deviation of the scaled test score. And now what we need to do is find the probability that a randomly selected student has a scaled test score of at least 90. How are we going to do this?
1 minus.
No,
No, not at all. That's so
not even close.
What the heck is that? 90 times 0.4x.
Nope.
Look at her. Oh my god, the hard part finally came.
This should not be that hard. In fact, someone's already said how to do it.
You idiot.
Plus
Plus
90
90
times
times 9.
bro.
No?
You just put the minimum in the stupid thing.
Nope.
You would do the little.
What are you going to do?
Dude,
times
you do the lower, the upper, the. It's
Oh, normal
I was literally
CDF.
saying bars. I was literally saying bars. Like right here, bro. This little key, bro. That's what I was saying.
Now, ladies and gentlemen, how do I write in probability notation what the question is asking? How do we write the probability that a randomly selected student has a scale test score of at least 90 using probability
Greater than 90.
P?
Greater than 90.
What's greater
Less
than
than 90.
what's greater than 90?
Why?
Y is greater than or equal to 90.
Oh, Lord.
And 90.
90.
No, the lower would be 7.
What? No, you're stupid, man. We're trying to figure
Oh,
out what's
yeah.
right. You're a stupid idiot.
What's the lower boundary?
90. Upper boundary's infinity.
Oh, it's actually 100.
It's really.
Lower is 90, upper is infinity.
Oh, I was
You're telling me
correct.
you're getting a 250 on the test?
Yep.
Maybe he likes to give
50
them
million.
extras.
This is a idealized distribution that goes from negative infinity to positive infinity. Now look here, you guys. I need to use the mean of y, the scale distribution. That is 78.8. The standard deviation of y was 15.2. The number one mistake is that people go back to the original data instead of using their transformed data. That's why the notation is going to be very important. All right, find your answer, please.
That's not child's play.
That's nice.
I only went every other day.
So despicable, absolutely
What a
utter.
problem, brother.
It's a bloody civil war.
Wait, what are we doing?
We're finding the answer, folks.
Oh.
Oh, right.
Come on.
Right.
Plug it in, kids. Plug it in.
Right.
I know, this stuff gets me going crazy too. What'd you get?
How do you get to the thingy again?
I got hey,
Second bars.
23%. 0.33.
Yeah, we beat you.
Point what?
0.2306.
0.231. You turned around and said, oh, and you just said it. That was wrong.